Assalamualaikum warahmatullahi wabarakatuh. My name is Aizad bin Azman, and today I would like to do my mini project presentation. Alright, for my title, I chose a food canning production line. So what I did was I tried to look at the general production line for food canning specifically. So and then I tried to examine it properly. I tried to see if it has any problems or if there's anything need improving. So what I have concluded is that generally these production lines will always have error. No matter how thoroughly or how perfectly built it is, you can never run away from error, machine error, human error, and all that. There are all chances of error will sometimes be low, but it will never be zero. So my problem is that um, error error can be quite an issue, so we can try to fix that. And at the same time, production lines sometimes can be quite inefficient at times. So what we can do is that so my plan for this project is that I would try my best to design or redesign the circuit to minimize and compensate for the errors in the given system, and at the same time I try to increase the efficiency of that production line. Alright, so this is a rough sketch of my design. So the general idea of this process is that the conveyor belt carries the food cans under the dropper, and then the conveyor belt moves it under the lid and seals it, and then it moves it under the tag stamp, which stamps it with details such as the expiry date and production date, and then it goes through the split gate here, which would distribute it between the supposedly packaging lines. So what I did here is that to compensate for error, I added a sensor underneath each of these actuators. So in a situation where an error happens, an error such as, okay, let's say one of these cans happens to fall off the conveyor belts and such. So generally these actuators, they would always run on a timer, on a cycle where all of them would always trigger at once. But I don't want that. I will try to prevent that, which is why I put the sensors down there, which would only activate the actuators if there is a can under it. So previously I said something about error. So okay, imagine if one of the cans are not aligned, is spaced a bit too far from each other. So imagine if there's only one can under the food dropper and one can under the TS and no can under the lid sealer. So only the food dropper and the tag stamp will be activated at the time because there was no can under the LS sensor. So with this, I can compensate for any severe errors, and at the same time I can probably stop any wasteful resources from being wasted. And then moving on to the split gate. For the split gate, my plan was to increase the efficiency of the production line. So what I mean by increasing efficiency is that since most of the time it's always a single line of produce, so I plan on putting a solenoid in the middle of these lines here. And what they do is that depending on whichever lane is open, the cans would go through that lane, and then after it reaches a certain amount, the solenoid will switch gates, it will switch sides, and move to the other lane. So this way, it can split into multiple packaging lines, so that we can increase efficiency and help ease the operations on the packaging side. Alright. Now for the demonstration of my ladder diagram. Alright, so here we have the main power control. I1 being the main switch and I2 being the main power switch. Here we have the conveyor controls. Then we have the actuator controls. Then here we have the split gate controls, the solenoid. Alright, so as you can see, each of these systems, they are actually separated into 3 mini systems: the conveyor belt, the actuators, and the solenoid. These 3 are independent of each other. They do not rely on each other at all. However, they do complement each other during production, during operations. And with that, I'll show a demonstration on how it works. So first things first, you turn on the power, which powers up memory 1, which powers every one of these systems. So we can start off with the conveyor belt. So the conveyor belt starts off. The conveyor belt, as you can see, it turns off conveyor belt in 5 seconds and turn on conveyor belt in 5 seconds, meaning that the conveyor belt moves for 5 seconds, and then 5 seconds it just stands still, and then it moves for another 5 seconds. So it's a constant rate of moving on the conveyor belt. So this way we can get a constant rate of cans moving on the production line. So, and then moving on, here we have the actuators. So the actuators, okay, what I did was that the actuators only comes online when the conveyor belt stops. During the 5 seconds that it stops, there's a 3-second window for it to activate. Hence we have the 3 and 7 seconds. So okay, something along the lines of the error I mentioned before about how the actuators only activate when there's a can underneath. So here I3, I4, I5 is the supposedly motion sensor for the production line. So as you can see, it's Q2, Q3, Q4 is the actuators. So right now, none of them are activated, even though the actuators has been going on and off. So let's say we turn, let's say there is a can at I3 and I5. So once the thing at 3 seconds, yep, Q2 and Q4 is activated for the 3 seconds, and then it's turned off. Okay, so next is the solenoid at the very end. So so how it works is that I set it to 10 cans per side. So since I6 controls the right side and I7 controls the left, so I6, okay, just set it all the way to 10. Once it reaches 10, observe Q5, 10, and then it switches to 6, meaning that it switches sides, and now the cans are heading to the left side instead. And now we use I7 to demonstrate the left side motion sensor. Then observe Q6 at the bottom here, and when it reaches 10, now it's Q5. Now the solenoid has turned around and make way for the right side to receive cans. Now we can just press I2 to kill the system, and yeah, that is the demonstration of the ladder diagram. Alright, so my conclusion is that automation is very beneficial to modern life. It is a very beautiful thing to happen in this day of industrialization. It really helps modernize whatever we have today. But of course, when it comes to automation, regardless, errors are always there. It's almost impossible to remove it, it's almost impossible to get rid of it. However, it can be minimized to a certain degree. We can minimize error to a point that it is minuscule, but it's still there. But yeah, and at the same time, If we can increase the efficiency of our production lines, that will make the world our production line yields more results and better produce. Alright, that is all for me. Thank you very much.